Ever wondered why alternating current gets a little picky and avoids the center of a wire? It seems weird, right? A wire is just a wire, but when you crank up the frequency, physics gets interesting. At first glance, a wire seems simple. You've got copper, current flows through it, and your gadget works. Easy. But once that current starts alternating really, really fast, a phenomenon called the skin effect kicks in. So, what is it? The skin effect is the tendency of an AC current to flow mostly near the outer surface of a conductor. It literally sticks to the skin of the wire, instead of spreading out evenly through the whole thing like direct current or DC does. At low frequencies, the current is pretty much uniform across the entire cross-section of the wire, but as the frequency gets higher and higher like kilo, mega, even gigahertz, the current gets pushed more and more towards the surface. When AC flows, it creates a constantly changing magnetic field around the wire. According to Faraday's law of induction, this changing magnetic field induces little swirling currents inside the conductor itself. We call these eddy currents. Now, these eddy currents flow in a direction that opposes the main current flow. This opposition is strongest right at the very center of the wire. The result? The main current gets pushed away from the center and squeezed into a smaller area near the surface. The higher the frequency, the stronger these induced fields become, and the thinner the effective conducting layer gets. This has a huge real-world consequence. The effective resistance of the wire actually increases with frequency. It's the same wire, made of the same material, but because the current is using less of the available copper, it faces more resistance. More resistance means more energy is lost as heat. It's like trying to force a 4-lane highway's worth of traffic down a single-lane side street. Things are going to get hot and slow down. This is why engineers have to think about skin effect all the time, especially in things like high-speed digital signals for your computer, RF systems for your phone and Wi-Fi, high-frequency, power electronics, and even in transformers and inductors. To combat this, engineers use clever tricks. They might use thicker traces on a circuit board for Hickory paths, or use special Litz wire, which is made of many tiny, insulated strands woven together, for high-frequency AC power. For high-frequency signals, they might use wider copper planes instead of thin traces. So, here's the key takeaway. Skin effect doesn't make the current disappear. It just means that less of the copper in your wire is doing all the work. And when a small part of the conductor has to carry all that current, things get inefficient and hot. Remember this: at high frequency, copper gets shallow.